All right, so this is 1.3 part B for college algebra notes. So here, our section objectives is to write and use mathematical models to solve real life problems, solve mixture problems, and then use common formulas to solve real life problems. Using mathematical models, the process of translating phrases or sentences into algebraic expressions or equations is called mathematical modeling. A good approach to mathematical modeling is to use two stages. Begin by using the verbal description of the problem to form a verbal model. Then, after assigning labels to the quantities in the verbal model, form a mathematical model or algebraic equation. When constructing a verbal model, it is helpful to look for a hidden equality, a statement that two algebraic expressions are equal. So this is just a strategy on how to do these problems. All right, so this problem says if a company offers a job with an annual income of $32,300, this includes salary and a year-end bonus of $500. If the company pays twice a month, what is the gross pay before taxes, for each paycheck? So here, okay, so on here, we've already shown you what the verbal model is. So the annual income equals 24 paychecks times the amount of each paycheck added with the added bonus. So we need to write an equation for this. So following this, I'm just putting things in where they go. So we have the annual income, which they gave us. 24 paychecks is because of the getting paid twice a month, and we know there's 12 months in a year. So twice a month, 12 months equals 24 paychecks. The amount of each paycheck, we don't know. And then the bonus we do know is $500. So then now we are just solving an equation. So we have 32. Well, actually, let's go ahead and move that over. So let's move the 500 over here. And that leaves us with 31,800 is equal to 24x. So then now we're at a nice basic problem. Divide by 24. X is equal to 1,325. And you're done. That's the end of that problem. You've answered the question that they asked you for, which is what is the gross pay for each paycheck. All right, so this slide it says a fundamental step in writing a mathematical model to represent a real-life problem is translating keywords and phrases into algebraic expressions and equations. The table gives several examples. So this is just to help you where it goes from keywords to verbal description to algebraic on the same line, just for you to be able to use as you do these problems. So another example. A job pays $20 per hour. After a 2-month probationary period, the hourly wage will increase to $21 per hour. What percent will be received after the 2-month period? So again, we provided you the verbal model that the raise equals percent times the old wage. So we're going to plug in things where they are. So the raise, 21. The percent, we don't know. The old wage is 20. So then here we're just dividing both by 20, and we're left with x equals 1.05, which if we're thinking percent, this we might be thinking, okay, so 105%. However, if you're talking about a raise, this means the raise is 5%. All right, another example. So problems involve 2 or more rates are called mixture problems. Percents must change to decimal form, like I just did in that last problem for my answer. So a total of $10,000 is invested at 4.5% and 5.5% simple interest. During 1 year, the 2 accounts earned $508.75. How much amount was invested in each account? So you got to start. So like here we have our verbal model. Interest from 4.5% plus interest from 5.5% equals total interest. Well, you need to define things. So we're going to start defining. So we're going to call this X. We're going to call this Y. And one thing we do know right away, we know that X plus Y is equal to our 10,000 So then we need to write a second equation, and we're doing a systems of equations here. So then the second equation is going to be 0.045x plus 0.055y is equal to the $508.75. Because again, I had to change the percents to a decimal. So then now I can look at this guy and say, well, that's the same thing. If I solve it for y, because I'm going to use substitution, I can now substitute 10,000 minus x where I see a y in the problem. So then now I have 0.045x plus 0.055y, which is now going to be represented by 10,000 minus x, is equal to 508.75. Now I need to distribute. So 0.045x plus, that first part is 550, minus 0.055x equal to the 508.75. So now combine like terms. And when I do that, I get a negative 0.01x plus 550 is equal to that 508.75. Subtract the 550 from both sides, and you have equal to negative 41.25. And when we divide, we get x is equal to 4,125. We like that because we know, if we look back, y is equal to 10 grand minus x. So my y value is equal to 5,875. So there I've answered. The 4.5% is at 4,125. 5.5% is at 5,875. All right, next problem. The Emporium has a $5,000 inventory in t-shirts and stuffed animals for souvenirs. The profit on a t-shirt is 28%, and the profit on stuffed animals is 19%. The profit for the entire stock is 23.68%. How much in dollars is invested in each total souvenir? So I'm going to write down some things that I know. All right, so you didn't have to have this be a longer video. I wrote out some things that we know. We know the total inventory is 5,000. We know the profit for t-shirts is 28% or 0.28. We know the profit for stuffed animals is 19% or 0.19. And we know the profit for the entire is 23.68% or 0.2368. I'm going to call X dollars invested in t-shirts, and I'm going to call Y dollars invested in stuffed animals. So we know the equation X plus Y is equal to $5,000, which we can rearrange that equation to be Y equals 5,000 minus X. And our second equation, we're going to use the decimals of 0.28x plus 0.19y is equal to 0.2368 times 5,000, because we have to figure out what that number is. In the next line, I'm going to replace the y with the 5,000 minus x. So we'll have 0.19 times 5,000 minus x. I now have done my math, which is 1,184. So then I need to distribute. So when I distribute, I get the 950 minus 0.19x. So now I'm going to combine like terms. When I do that, I get 0.09x plus 950 equals 1,184. Let's subtract the 950. When I subtracted that, I got 234, and then I divided by 0.09, and I got x is 2,600. So I can go back up here, and I can identify, okay, so that means this is 2,600. To find y, it's 5,000 minus 2,600, which is 2,400. All right, another mixture problem. A coffee shop sells a blend of two types of coffee beans. Colombia beans cost $9 per pound. Ethiopian beans cost $12 per pound. Shop wants to make 30 pounds of a special blend that will sell for $10 per pound. How many pounds of Colombian beans and how many pounds of Ethiopian beans should be used to make the blend? All right, so Colombian we know is $9 per pound. Ethiopian is $12 per pound. We want 30 pounds blend for $10 per pound. X equals Colombian. y equals Ethiopian. So we know for sure that x plus y is equal to 30. And then now we can, Colombian is also going to be 9x. Ethiopian is going to be 12y. So then our other equation is going to be 9x plus 12y is equal to 300. So again, I go back up here and I say, okay, let's make y equal to 30 minus x. Let's replace that. 9x plus 12 times 30 minus x. That should be a 300, sorry, is equal to 300. Start distributing. Combine like terms. Subtract 360. Divide by 3. X equals 20. So then when you go back up here, you know that the Colombian amount would be 20 pounds. Ethiopian amount would be 10 pounds. All right, so these are actually the beginning of your assignment. Write a mathematical model for the problem and solve. One positive number is 7 less than 3 times another number. The sum of the two numbers is 121. So the first thing you have to do is write your two equations. You know, when you add them together, you get this. And then writing out this other equation, you get that. So again, take your pick. I'm going to go ahead and rewrite this as 121 minus x. And then I'm going to substitute it in over here. So 3x minus 7 is equal to 121 minus x. As I'm looking at what I'm doing. Okay, so then thus 4x is equal to 128. So x is equal to 32 when I'm running that through. So then my two numbers are going to be 32 and 89 because of the math problem up here. Take your pick which one. 121 minus 32 is 89. All right, this next problem says find two consecutive integers whose product is more than the square of a smaller number. Consecutive integers, they're not even or anything. They're literally in order. And so we have x times x plus 1 is our consecutive integers is equal to 10 plus x squared because the smaller one would be x squared. So then we distribute x squared plus x is equal to 10 plus x squared. Our x squareds cancel and you're left with x equals 10. So then our numbers are 10 and 11. And then last but not least, we ask you to find the price of a shirt after a 25% discount is $18.71. Find the original price. So when I put this in a verbal form, I know that sale price equals list price minus the discount. Okay, so then I know sale price is my $18.71. List price, I don't know, other than the letter L. And then my discount would be 0.25 L. So then I continue on. 18.71 is equal to 0.75 L. And then I end up with L equals $24.95. $24.95.